Alright, as we continue our unit on exponents, we're going to take a look at rational exponents, sometimes known as fractional exponents. What those are is, we'll find out what that means, but we just apply the same rules of exponents. But what we're going to come into contact with is something like 49 to the 1/2 power. What does that mean? We'll find out that 49 to the 1/2 power equals 7. That's not a very good looking 9, but anyway. So we'll apply the rules of fractional exponents and find out how that works. First of all, let's just review what we know about square roots and cube roots. Just take some time to brainstorm examples of the symbols, definitions of square roots and cube roots if you can remember them. Pause the video and restart it when you're ready to take a look at what I have. Okay, so the symbol for a square root is the radical. What it means is the number, what number multiplied by itself gives us x. So for example, what number multiplied by itself gives us 49? It would be 7, because 7 times 7 is 49. Cube root is similar. We use the radical, but a little 3 outside here. There's the understood 2 and a square root. It means the number, when cubed, gives us x. So for example, the cube root of 27 is 3, because 3 times 3 times 3 is 27. So let's look at why this works. We all know that when you take the square root of a number, we write the square root of a. We want to write that as square root of a as a to the k. We want to figure out which exponent we use when we take a square root. So by definition of square root, b squared equals a. B is the number that we get when we take the square root of a, because a number times itself gives us another number. So let's say that 7 squared is 49. Let's use that example. And we want to figure out, because we know if I take the square root of 49, that gives me 7. We want to figure out what exponent we use with 49 to give us 7. Maybe I should use k there. So 49 to the k equals 7. So what value of k will we use? So we know if we substitute in, so let's say we want to get a, so a to the k, okay, or 49 to the k, and we want to get 49. So we know when we take the square root and the square, they cancel each other out, and it'll give us the same thing. So taking that, let's say which exponent is taking the square root, so that a to the k squared gives us a. So a to the k to the second is a to the 2k, and we know that's still a to the first over here. So by proof, we know that since the bases are the same, the exponents must be equal. So 2k equals 1. So we got to find out which value of k is going to make the expression 2k equal to 1. So we solve for k and we get k as a half. So we know that a to the half is the same as square root of a. So I would say that 49 to the half power is the same or is equal to 7. So square root is the same as a half power. Another way to look at that, 49 to the first power, and we take the square root of that, numerator, denominator, in that exponent. So here's some other examples of how that works. A to the half is a to the first, and take the square root of that. A to the 1/3 would be a to the first, the cube root of that. So the 1/3 exponent is the cube root. And a to the 3/2, well, I know 3/2 if I use my property of exponents. I know that a to the half times a to the half times a to the half, because I add exponents when I multiply at the same base. So it's really taking the square root of a times the square root of a times the square root of a, which another way to write that would be a. I've got multiplied a 3 times under the radical, so a to the 3rd, and we got the square root of that. So you can see where the top number comes, the numerator, that's our exponent, and the bottom, the denominator, is which root we are taking. So if it's a 3, it's the cube root. If it's a 2, it's the square root. So let's do some work with that now. So in our first example, we have 16 to the 1/2. That's the same as square root of 16. which would be 4. 25 to the negative 1/2, well, that's the square root of 25 to the negative first power. Well, I can take the square root of two ways we can go this. So we can take the square root of 25, so that would be 5 to the negative first power. So if I take the square root first and then I work with the exponent, and then to the negative first power, it's like dividing, so 1 over 5. Or if I'd prefer to take the exponent first, I have the square root of 1 over 25, because I'm dividing by 25. Then I take the square root of that, square root of 1 over square root of 25, which would be 1 over 5. So you can either evaluate the exponent first or the radical. 9 to the 5/2. So we've got 9 as our base, 5 is our numerator, so that's our exponent, and 2 is the root. So in this case, if I did the exponent first, that can be a very large number. So I'm going to take the radical, the root first. So let's take the square root of 9, which is 3, and then let's raise that to the 5th power. So 3 times 3 is 9, times another 3 is 27, times another 3 is 729, and got to check my calculator for the last one. 2187. Or that's too much. 243, I missed one in there. So 3 to the 5th is 243 when we evaluate that. And notice if I would have gone the other way, 9 to the 5th first, that would be 59,049, which is a larger number. Then if I want to evaluate the square root of that, that would give me 243 as well. So it's just a matter of which numbers you want to work with. So 4 to the negative 3/2 is 4 square root to the negative third power. Notice I don't need to put this 2 here every time. I'm just doing that to show you the connections here between the exponent and the radical sign. So I'm going to take the square root first. So square root of 4 is 2, raised to the negative third power, which means I'm dividing by 2 3 times. 2 to the third power is 8, so 1 over 8 will be our solution there. Okay, so those are square roots. Let's move on now to the cube roots. 27 to the 1/3. So 27 to the 1/3 is really the cube root. Which number times itself 3 times gives us 27. That would be 3. We looked at that one earlier. 8 to the negative 1/3. 8 to the negative first power. It's a cube root. I'm going to evaluate the cube root first. Well, 2 times 2 times 2 gives me 8. So it's 2 to the negative first, which I can simplify as 1 over 2. 64 to the 4/3. We've got the cube root of 64 raised to the 4th power. If I raise 64 to the 4th power, that's going to be a very large number. So I got to think of what number times itself. 3 times gives me 64. I think that's 4. 4 times 4 is 16. Times another 4 is 64. So then 4 to the 4th. Let's see. 4 times 4 is 16. Times another 4 is 64. Times another 4 is 256. And finally 125 to the negative 2/3. So that's a cube root. We're raising to the negative second power. So I'm going to evaluate this root first. I believe that's 5, because 5 times 5 is 25, times another 5 is 125. So 5 to the negative second, 1 over 5 squared. So that would be 1 over 25. All right. Now let's combine what we know about the properties of exponents and add these rational exponents in there. So 12 to the negative 1/2 times 12 to the 5/2. Remember, when it's the same base, I can add exponents. So 12 to the negative 1/2 plus 5/2. And negative half plus 5/2 is 4/2, which would be 2. So 12 squared is 144. Next one, I have 6 to the 4 thirds times 6, which is really to the first power, over 6 to the 1 third. So we multiply on top, same base, we add those exponents. So we have 6 to the 4 thirds plus 1, which is 3 thirds, all over 6 to the 1 third. Add exponents on top, I get 6 to the 7 thirds over 6 to the 1 third. Now when we divide with the same base, we subtract exponents. So that'll leave me with 6 to the 7 thirds minus 1 third is 6 thirds, which 6 divided by 3 is 2. So 6 squared, which is 36. All right, so why don't you try those next 3 examples there. Try to move my face out of the way. Start the video when you're ready to check them over. Okay, so 100 to the 3 halves is 100 cubed, the square root of that. So square root of 100 is 10, cubed is 1,000. 121 to the negative 1 half is 121 to the negative first, square root. So I evaluated 121 to the negative first is 1 over 121. Square root of that is 1 over 11. 9 to the 7 halves times 9 to the negative 3 halves, add exponents, so 9 to the 4 halves, which is 2, so 9 squared is 81. So we've learned how to evaluate exponents with irrational exponents and connect those to cube roots and square roots.